Hello students. Student, in the previous lecture just we have to discuss about the basic table related to the inverse trigonometric functions, where we have to discuss about the domain and principal value. Student, that should be the very important table for us, because today we are going to start the basic properties of inverse trigonometric function. Then definitely in each and every kind of property we will just discuss about that table, means where we have to see the particular domain of inverse trigonometric function, as well as we have to also see the principal value. Is it to be clear? So I think all of you have to learn this particular table, so that we will just discuss about the basic properties. And today student, we will just start with a very basic property, and this particular property is to be used in the exercise 2.1 as well as in the exercise 2.2 also. Is it to be clear? So before starting the properties, again I am just repeating the concept of this that table. And student, various kind of graph we have to already discuss, means where and how we will just calculate the domain and particular principal value of the given inverse trigonometric function. We have to just discuss these things in the previous video, so you can just think about that part. So in this particular part, student, there are certain sine inverse x. Suppose we have to take next cos inverse x. After that we will take the tan inverse x, cot inverse x, then we can say that sec inverse x and cosec inverse x. Is that to be clear? Student, we have to just see about the domain part as well as the principal value of each and every function. Principal value, because this will be the very important regarding to the various kind of properties of these functions, and we will use this concept. So basic, what should be the domain of this particular function? So you can say that -1 to +1, and principal value of this particular function is to be taken from -π/2 to +π/2. Is it to be clear? Means we can just provide the input from this section, and the output of this function will lie in this interval always. Next, cos inverse x, again the domain of this function is said to be -1 to +1. As well, you can say that the principal value of this function is to be taken from 0 to pi. Is it to be clear? Next, tan inverse. Tan inverse means the domain is to be taken as set of real number that should be represented as r, because you can just put any kind of real number as the input part of this inverse function, but the output will be provided uh, by this function from -π/2 to +π/2 open interval. Means we will just consider the open interval only, no closed interval, means no particular boundary values are to be get included here. next we are taking the cot inverse x. So the domain of this cot inverse x is again found to be r, as well as you can just see about the principal value. Then open interval 0 to pi, means in this section we have to just uh, not include the boundary values 0 and pi, but in between values we have to just include. Is it to be clear? Similarly, in the sec inverse x, the domain is to be found as r minus of -1 to +1. So in this particular case of sec inverse x, just we are saying that this particular value -1 to 1 is to be not included in r. Except of these values, you can just provide any kind of input, no problem. Next, principal value. Principal value means this is to be 0 to pi, but except of this one value, that should be pi/2, because at pi/2 this particular sec function or its inverse will not be defined here. Next, cosec inverse, then domain is again said to be r minus of -1 to +1, and the principal value is to be taken from -π/2 to +π/2 except of this 0, means we will not consider this particular value 0 in the case of principal value. So in the last class, just we have to discuss about this table, how these values are to be obtained. We have to see the basic graph, means we have to just see the basic function of trigonometric, then we will make that function as bijective function. After that we will get these type of principal values. So easily student, you can just observe each and every value just by using the graph, and after that we have to just learn each and everything. What should be the domain of each and every inverse trigonometric function is what we have to keep in mind these things always, because if we will keep in mind these things, then definitely you will able to solve the particular properties, and you can just able to understand the concept of inverse. Each and everything you will understand, but if we have to just know about this particular table, otherwise there are some issues are to be there. Somewhere your answer should be right, somewhere the answer is to be wrong. So we have to make the proper concept, so that this table is to be very important for us. Which trigonometric inverse trigonometric function is to be get simplified, then we have to see the particular domain, as well as we have to see the particular range, or you can say that the principal value, means output of this the function is to be lie from where to where, we have to know this part, as well as the input part is to be taken from which part to which part, we have to see this thing. So each and every kind of uh, knowledge related to the domain and principal value of each and every function we should have to keep in mind. So today student, basically after knowing this particular table, we have to just started the basic properties of inverse trigonometric function, and only one property we will discuss before the exercise 2.1, because this particular property is to be very important for us, and this will be used in exercise 2.1 also. So we have to keep in mind the concept, and according to that we have to just simplify them. Is that to be clear? So we will start the basic properties of inverse trigonometric function. Before that, again student, you can just note down this particular thing just after pausing the video, but you have to keep in mind always. Again and again I am saying this thing. So next we will start the basic properties of inverse trigonometric function, of inverse trigonometric function, inverse trigonometric functions. So we will start the basic properties of inverse trigonometric function one by one, and we have to see the things carefully student, because here some basic properties already I think you know and you will aware about that of, but we have to keep in mind the deep knowledge of these properties, means the domain is what, principal value is what, according to that we have to just discuss this thing. So we will take the very first property. In this first property, first of all I will just tell one important thing. Suppose it is to be written as sine of sine inverse x. One thing we have to write like this, and another thing we have to write like this, sine inverse of sine x. So some of the student will just say this answer is obtained as x. This answer is again obtained as s, because they are saying that this sine inverse will vanish this particular sign, means this sign will vanish with respect to this sine inverse x, or this will be cancelled out with this part, or this will be cancelled out with this part. Student, uh, answer is right, no problem, x, but it is not said to be in each and every case of x. Means if we have to write this property and this property up to this part, then definitely it should be considered as the wrong, because definitely if we are not mentioning the proper x here, then you can say that the property is not said to be properly declared. Is that to be clear? So we will say that this answer is x, but in what cases this is found to be x, and this is also said to be x, but in what cases it is found to be the x. So for that, again we will just take the help of domain of sine and sine inverse. So basically I think each and every student know very well about the sine theta function, and sine theta function has the domain r2 minus 1 to plus 1, and similarly for the sine inverse theta, you know very well this particular domain is minus 1 to plus 1, and the output or principal value is to be taken from minus pi by 2 to plus pi by 2. So whole work is to be dependent on the domain and principal value of the given functions. Means if we have to keep in mind this thing, then you can just describe this property. Up to this stage, this property is not said to be proper. Is it to be clear? Answer should be x, but in what cases we will get x, in what cases we will not consider as x, and how the question is will be asked, and how we will simplify the things. All the things are to be dependent on this particular domain and principal value of given functions. So we will take this function first of all. In this particular function, student, you can say that this is the sine inverse x, or this is sine. So first of all, you can say that this is the composition of the two functions. Student, in the previous lecture number 1, just we have to discuss about the composition of the two functions, where in this case the sine inverse and sine inverse trigonometric function as well as the trigonometric function, both are to be composed with each other, and we will say that answer is obtained as x or not. So first of all, you can just tell me one thing. In this particular part, student, this particular function is taken as sine inverse of x. So you can check the domain of this sine inverse x, means in this case sine inverse, you can take the value x belongs to minus 1 to plus 1. So in this case, what type of values we have to taken here? Minus 1 to plus 1, because according to the function we have to take the suitable input from the domain. So now these particular values are to be inserted here, then this particular function will work. Now output of this particular function. So you can say that the principal value of this function will lie from minus pi by 2 to plus pi by 2. So definitely the answer of this whole part will be from minus pi by 2 to plus pi by 2. And student, this particular output part will work as the input of this outside function, you know very well. So definitely if we have to take the sine function as output, then if we will eliminate this part, then particular sine x will provide the answer as minus 1 to plus 1. So according to this, with respect to this part, we have to write this part, and according to this function, finally we have to solve this function, then we will get the answer of x from minus 1 to plus 1. So again we can say that x belongs to minus 1 to plus 1 closed interval. Is it to be clear? So basically if both the parts we have to just see, about this x we are saying this thing and about this x we are saying this thing, then definitely both are the same thing. So definitely student, this property will hold. This property will hold like in such a way, sine of sine inverse x will be x if x belongs to minus 1 to plus 1. Suppose we are just not writing this part, then this property does not hold, student. So basically we have to keep in mind, and definitely this particular domain and codomain of each and every function is to be very important for us. Suppose we have to take a suitable example to understand this property in more better way. Suppose anyone else ask about the answer of sine inverse 1 by 2, then what should be the answer? So definitely student, this answer should be x, because according to this property you can say that this will written as x, but when this x belongs to the minus 1 to plus 1. So definitely we have to check this particular value 1 by 2. So definitely 1 by 2 will lie in this region. So definitely you can say that this particular answer is said to be 1 by 2. But suppose another example we have to take, sine of sine inverse 5. Suppose it is to be asked, then what should be the answer? Some of the student will provide the answer as 5, but it is not 5, because according to the property what we are saying, that this particular part will be written as x only in this case whenever x belongs to the minus 1 to plus 1. So here you can check this particular value as 5. So 5 does not belongs to this minus 1 to plus 1. So you can say that cannot be determined. Cannot be determined. Is it to be clear? So basically student, this particular answer cannot be determined. Why? Because this particular 5 does not belongs to minus 1 to plus 1. You can just give the answer, and we cannot transform as 5. Somewhere some of the values we will see in this section, we will change the particular x, means transformation is to be applicable, as you have to discuss in the class 11th also. But here no particular type of transformation will be applicable, because the numerical value is said to be 5 here. So only 5 we will see. Then according to the 5 student, no transformation will be there. Then such type of answers cannot be determined by using this property, and this property will does not provide the answer as x in such type of cases where input is to be outside the given interval as minus 1 to plus 1. Is it to be clear? So you can just see these examples. In these examples, one of the answer is to be written as 1 by 2, but this answer is does not determine, means this cannot be determined, means you can just see about this particular value 5. This is the very important part. Is it to be clear? So in this section, if we have to write up to this stage only, then definitely student, you are not declaring the property clearly. So this proper statement of the property will be from this part to this part, means we will just specify this particular x, otherwise this property does not hold anywhere else. Is it to be clear? Similarly, the another thing we will see here, sine inverse of sine x will be x. Sine inverse of sine x will be x. So student, first of all we have to see this inside function. Again the composition of the two functions are to be there. So this function we have to take here sine x. Then definitely you can just tell the output of this function. Output of this function will be lie from minus 1 to plus 1, you know very well. So this output will be taken as the input of this function. So what can be input of this function? Definitely both are the same here. So there should be no problem in the output values provided here. Is it to be clear? But what should be the output of this function? Means the output of this function is to be checked here. Principal values of this sine inverse will be taken from minus pi by 2 to plus pi by 2. So definitely student, this particular part will provide the answer as minus pi by 2 to plus pi by 2. So if we will take this part, we will take this part x, then this particular x, you can say that this particular x belongs to R. This particular x belongs to R, because here you can say that the domain of this particular function is said to be set of real number. But after providing the answer, after simplifying this function, this particular function will provide the output in this interval from -1 to +1. Now this particular output will behave as the input of this function. So definitely in this function, what type of input you can just give here. So again, you can check this codomain and this domain will be same. So there should be no problem in the output values of this. These all values will be processed by this sine inverse x. Now what should be the output of this function? So definitely in this whole x, for this whole x, you can say that x belongs to minus pi by 2 to plus pi by 2. Is it to be clear? So finally this particular function, this whole particular function will provide the answer in this interval minus pi by 2 to plus pi by 2. Is it to be clear? Now you can just take the intersection of this part and this part. So definitely this part will be also the set of real numbers. In the case of real number, you can just consider all kind of real numbers you can take, but here only the real number minus pi by 2 to plus pi by 2. You can take the value of pi in radian as 3.14. So this is 3.14 upon 2 and this is 3.14 upon 2. So definitely you will get the some kind of real number, no problem. So we have to take the intersection of both the parts. So both the x will be get satisfied here. So definitely if we have to write the proper statement of this property, then we will write sine inverse of sine x will be taken as x if x belongs to minus pi by 2 to plus pi by 2. Is it to be clear? So this thing we have to just mention here, student. Otherwise, definitely you will feel the some basic problems here. Is it to be clear? Now, suppose we have to take a important example to understand this property. Suppose sine inverse of sine 3 pi by 5. We have to just calculate the answer of this part. Then what should be the answer here? So if we will just calculate the answer, sine inverse of sine 3 pi by 5, then some of the student will provide an answer as 3 pi by 5, because they are saying that this sine will be vanished with the sine inverse x, but it is not said to be the true, because here according to the property this sine inverse of sine x will be taken as x. In what cases? In this case, if we are taking the x from minus pi by 2 to plus pi by 2, means you can say that in this particular case this is plus pi by 2, and here if we are going the clockwise, then it is minus pi by 2. So it will be taken from the first and fourth quadrant, then you can take this value as here, otherwise we will just not take this value. So you can just check the value, this 3 pi by 5. So definitely student, pi in the degree, pi is taken as 180 degree. So 180 divided by 5, 36 into 3, 108 degree. So if we will convert this angle 3 pi by 5, then it will become 108. So 108 will lie in second quadrant. So definitely this particular sign will not cancel out with this sine inverse, and we will not obtain as the answer as 3 pi by 5. So in such type of cases, we have to just transform. And student, the transformation you have already read in the class 11, because some angles, allied angles, we have to just simplify where, then definitely we have to just transform the each and every angle. So the transformation part is to be very important here. So if we are knowing about the transformation, then you can just simplify this answer, otherwise you cannot simplify the answer. So if we will write this part like this, sine inverse of sine, now this 3 pi by 5 can be written as pi minus 2 pi by 5. So this will be the case of transformation, where we have to split this particular angle in two parts, where the splitting can be taken along with the pi by 2 or pi. So somewhere pi plus, somewhere pi minus, according to the requirement we have to apply the operation. So 3 pi by 5 can be written as pi minus 2 pi by 5, definitely. Now student, you can say that sine pi minus theta, and this sine pi minus theta will become as sine theta here, you know very well, because in second quadrant this particular sign will be taken as positive, so it will be written as 2 pi by 5, because sine of pi minus theta will be again written as sine theta. Now sine inverse of sine 2 pi by 5. So definitely now the transformation will be there, because this particular angle does not satisfy with the given interval minus pi by 2 to pi by 2. So definitely now you can check this value again, 2 pi by 5. So 2 pi by 5, pi by 5 is 36, 36 multiplied by 2 is 72. So 72 degrees definitely lie in this interval minus pi by 2 to plus pi by 2. So now you can use this property, and this answer should be taken as 2 pi upon 5. There should be no problem, because here you can say that this 2 pi by 5 belongs to minus pi by 2 to plus pi by 2. Is it to be clear? That's why we can write this answer here. Now again a very important case student here. In this very basic first property, we are saying that sine of sine inverse x will be x if we are taking x belongs to -1 to +1, and this sine inverse of sine x will be x if we are taking x from -π/2 to +π/2. Is it to be clear? So this thing is to be the very important for us. We have to just keep in mind these examples. Suppose any other example we have to take here. Suppose it is to be asked sine inverse of sine pi/6. Suppose a very basic question is to be given. Now we will just say that this sine inverse will cancel out with this sine if and only if this particular angle will lie in this interval. We have to check this thing. So you can say that pi/6. So pi/6 will be equals to 30 degree. So definitely 30 degree will lie in this first quadrant only, -π/2 to +π/2. So definitely there should be no problem in such kind of answer. You can just write the answer as pi/6 directly. But before writing the answer, just we have to check this value will lie in this interval or not. Is it to be clear? So basically student, in the very first property, why we are saying these conditions, because here we have to just keep in mind the particular principal value and domain of each and every inverse trigonometric function as well as the trigonometric functions, because here the trigonometric concepts are again to be used, which are to be already written, we have to read in the class 11. But student, the some transformation, some allied angles values, and in which quadrant the particular function will provided as the positive or negative value, we have to keep in mind each and every part. Then we can just able to simplify these things. Otherwise we will face the some problems. Is it to be clear? So we have to just keep in mind the concept and we can just use the property in a proper way. So we have to just remember the conditions and how the conditions and why we are writing these type of conditions. We should have to keep in mind the proper concept here. So student, now I will just write this for first property again, but before that you have to pause the video to note it down the all these things, because the explanation part you can just see here with the some example or some of the practical examples we have to take here. But here if we are just knowing related to the property, then what is the basic property we have to write. And now student, similarly this particular property is to be defined for each and every inverse trigonometric function, like cos of cos inverse x, tan of tan inverse x, cot of cot inverse x, sec of sec inverse x, cosec of cosec inverse x. For each and every kind of trigonometric function or inverse trigonometric function, we have to just define this basic first property. So in this basic first property, we have to include the 6 cases, because the total inverse trigonometric functions are 6. So each and every trigonometric function we have to just discuss here. So before taking the proper format of this part, we have to just note down after pausing the video. So the next part, we have to just write the basic property in this first property. So the very first part is to be written like this: sine of sine inverse x. Sine of sine inverse x will be taken written as x if x belongs to -1 to +1. Is it to be clear? Similarly, in this parallel case, we have to write this property as sine inverse of sine x. Sine inverse of sine x will be taken as x if x belongs to -π/2 to +π/2. Is it to be clear? So in this very basic first property, we have to just keep in mind this concept, because we have to just learn what should be the domain of that function, what should be the principal value. According to that, we have to define the particular inverse trigonometric function, because whole inverse trigonometric functions cannot be defined for the whole domain. We have to just restrict the domain first of all. After that, we will just get the value of each and every kind of inverse trigonometric function. So we have to keep in mind this thing, domain and principal value, what should be output, what should be the input, each and everything we have to just think about here. Is it to be clear? In this case, one more thing we have to say that if in this case we are writing if x does not belongs to -1 to 1, then answer cannot be determined. Answer cannot be determined. We have to keep in mind this thing always. In this case, we are just saying a very important note: if this x particular x, sometime this particular x does not belongs to this part, then definitely we cannot transform this x. Means no transformation is to be applicable in this particular type of property, and where the answer cannot be determined. We can say that this particular value does not belongs to this part, so answer cannot be determined here. But in this case, if x does not belongs to minus pi by 2 to plus pi by 2, then transformation of x, then transformation of x is applicable in such a way, that x belongs to minus pi by 2 to plus pi by 2, and we will just calculate the answer. Means here we cannot say that answer cannot be determined, but in this case we are saying that the answer cannot be determined. So we have to keep in mind this thing. In such type of cases, we have to suppose sometime this x does not belong to this part, then definitely the transformation of x is applicable, and in the applicability in such a way that we have to transform the x that should belong to the minus pi by 2 plus pi by 2. Suppose we have to take an example to elaborate this thing. Suppose here it is to be written as sine inverse 7. Then definitely student, you cannot say that, you can say that this particular answer cannot be determined, because this 7 does not belongs to minus 1 to plus 1. So you can say that answer cannot be determined. Is it to be clear? So such type of answers cannot be determined in this case. Suppose we have to take another example like this. Suppose sine inverse 3 by 4. Then what should be the answer? In this case, definitely this 3 by 4 we have to check. 3 by 4 definitely will lie in this interval minus 1 to 1. So definitely in this case you will obtain the answer as 3 by 4. Is it to be clear? But suppose here this particular value does not belong to this, then we can say that answer cannot be determined. But in this case, suppose any question we have to take here, sine inverse of sine 3 pi by 4. Suppose we have to write this thing, and we can just find out the answer. So definitely again in this case, if x, you have to check this 3 pi by 4. So definitely 3 pi by 4 will lie in the second quadrant. And you can say that this 3 pi by 4 does not belong to this interval. Then what we will do? Then we will transform this particular x in such a way that this x belongs to the minus pi by 2 to plus pi by 2. And you know very well about the transformation, student. This is the topic of class 11. You have already read in this class 11 the basic kind of transformations, how the particular x is to be get transformed. We have to see this thing. So in such kind of examples, we will just say that this sine inverse, and here 3 pi by 4 can be written as pi minus pi by 4. Pi minus pi by 4. Is it to be clear? Now you can say that this sine of pi minus theta. So sine of pi minus theta is again said to be sine theta. So definitely you can say that this sine inverse of sine pi by 4 will be there, and this is sine pi by 4. Now you can check this particular x, pi by 4. So pi by 4 definitely now belongs to this particular part. So we will transform the x in such a way that this particular x belongs to the minus pi by 2 to plus pi by 2. Means we have to keep in mind, means after transforming the x, we have to keep x like in this interval minus pi by 2 to plus pi by 2, and you will get the answer as pi by 4 here. And definitely student, here you can just understand this thing, why we are writing this thing. So here the some kind of transformation is to be get required, we have to keep in mind always. Is it to be clear? So in this particular property, what we are saying, sine of sine inverse x will be x, but in this case when x belongs to minus 1 to plus 1. In this case sine inverse of sine x will be x, but where x belongs to minus pi by 2 to plus pi by 2. Just I am just explaining this part and this part. This is the very important part. This will hold, then the particular property you can use. Otherwise in such kind of questions, we can say that answer cannot be determined. And here suppose this x does not belong to this part, then we have to just transform the particular x, and after that we will obtain the answer. Is it to be clear? So the next part we have to take, student, as cos of cos inverse x and cos inverse of cos x. But before that, pause the video to note it down these examples, and we have to keep in mind these properties. So the second part of first property we have to take. We are saying that cos of cos inverse x. Cos of cos inverse x will be again written as x, and again student, we are saying that this x belongs to the minus 1 to plus 1, and similarly here we can say that this particular cos inverse of cos x, this particular part will be taken as x, but in what cases? If x belongs to closed interval 0 to pi. How this particular part and this particular part is to be get written, we have to see this thing now. So student, in this particular part, you know very well the two things, means here you can say that we know that basically the cos theta function, you know very well about the cos theta function. Domain is said to be R and range is said to be plus 1 to minus 1. And here cos inverse of theta, suppose we have to take, then domain is minus 1 to 1, and the principal value we have to know about this principal value are 0 to pi. Now we have to check this thing. Now for this property we are saying that this is x. So this particular x is corresponding to the cos inverse x. Corresponding cos inverse means the domain of cos inverse x is minus 1 to plus 1. So definitely this x belongs to this minus 1 to plus 1. After that, this particular value will give answer as 0 to pi, and definitely student, this particular answer is to be given by the cos function. Outside function is cos, so definitely cos function will provide answer from minus 1 to plus 1. So definitely in this case, this particular x and this particular x will satisfy this condition minus 1 to plus 1. Is it to be clear? That's why we are writing this. In this case, the inside function is cos x. So definitely the output of this cos function will be from minus 1 to plus 1. But outside function is cos inverse x. Then what should be the output of this function? So definitely here output of this function means cos inverse. So cos inverse will provide the output at 0 to pi. So definitely this x belongs to R, but this x does not belongs to R. This x belongs to 0 to pi. Then we have to take the intersection part where both the x will be get satisfied. So that we have to write here x belongs to 0 to pi, and here thus we have to write the x belongs to minus pi to plus minus 1 to plus 1 closed interval. Is it to be clear? So these properties are to be just mentioning a student on behalf of the given functions, domain and principal values. We have to keep in mind these things. Suppose we have to take an example like this, cos of cos inverse 2, then what should be the answer? Again student, cos of cos inverse 2, if we will evaluate here, then cos of cos inverse 2, then we will not say that this is 2, because before writing 2 we have to just check this 2 whether this 2 belongs to this interval or not. So definitely this particular 2 does not belong to this interval. So we can say that you are saying that answer cannot be determined. Answer cannot be determined. In such a way student, we cannot transform this particular x, and thus we are saying that answer cannot be determined in such a cases. This is the very similar part as we have to discuss in the sine case. Suppose in this particular part any question should be like this, cos inverse of cos 3 pi by 4. Suppose we have to take the question, cos inverse of cos 3 pi by 4, then what should be the answer? Definitely student, cos inverse of cos 3 pi by 4, then we have to say that cos inverse of cos x will be x, but where we have to just declare the x will be taken from 0 to pi close interval. So definitely cos inverse of cos 3 pi by 4. So cos inverse of cos 3 pi by 4 means this x is to be checked whether this particular 3 pi by 4 will lie in this interval 0 to pi or not. So definitely student, you can check this part, 135 degree. This 3 pi by 4 means 135 degree, and this is 0 to 180 degree. So definitely this particular part will belong to this part, and if any x belongs to this part, then directly you can say that the answer is to be taken as 3 pi by 4. So in these kind of property, what should be the important thing? We have to just keep in mind the particular x, means x should be lie from where to where, and it will be totally dependent on the principal value and domain of the given functions. Is it to be clear? So definitely students, such kind of properties are to be very important in the exercise 2.1 and in each and every type of trigonometric function, as well as you can see the these type of property, use of these type of properties in the entire calculus also, where in the case of differentiation, in the case of integration, we have to just see such type of functions. Then whether this particular part will be cancelled out with this part, it will depend on the particular given x, and x is what? Definitely if outside function you can say that, then this particular is inverse. So this inverse will provide the answer in the principal range. So the principal range of this x will be taken from 0 to pi. Is it to be clear? Here the particular function, outside function, is to be taken as cos x. So definitely cos x is to be there, then answer of cos x is to be always found to be from -1 to +1. That's why we have to say that this is x belongs to the closed interval -1 to +1. Is it to be clear? So again the similar kind of things we are saying that, and again in this case, suppose this x does not belongs to this interval, then we can say that answer cannot be determined. And here if we have to write here, if x does not belongs to 0 to pi, then transform the x, in such a way that, this particular x belongs to 0 to pi. This thing we have to keep in mind. Again we are saying the same thing. In this case, if this x does not belong to this part, then answer cannot be determined, means we will not say about the answer part. But in this case, suppose this x does not belong to this 0 to pi, then again the student we have to let's see the examples in the last sine inverse of sine x, where we have to just transform the particular x, and according to that we have to just provide the answer. Is that to be clear? So we have to keep in mind these things, and according to that we have to just process the basic phenomena, and definitely you can able to find the particular answers. Is that to be clear? Now the things are to be simplified in this way for each and every kind of trigonometric function. So we will take the next tan of tan inverse x as well as tan inverse of tan x. Both are to be taken, but in what cases they are to be possible, and how we will write the particular kind of result, we will say. So in the third part, we are saying that tan of tan inverse x, this will be taken as x if this particular x belongs to R. We are saying that this particular x belongs to R, because here just we have to see the region behind this, and similarly we can write this property as tan inverse of tan x. Tan inverse of tan x will be taken as x if x belongs to open interval minus pi by 2 to plus pi by 2. Now you can see the region behind this particular x belongs to R, or you can just see the region behind this from x from minus pi by 2 to plus pi by 2. So definitely student, you can just check this outside function always. Outside function is tan function. So you know very well this particular tan function has the domain and range. So definitely if we have to define the tan theta, then tan theta is to be taken from R to you can say that this particular tan theta is to be defined from you can take the value of tan theta R minus of 2n plus 1 into pi by 2 to R. This is the particular answer of this particular function tan theta. So in this particular tan function, you can just check the output. Output should belong to the real number. And in the case of tan inverse, theta, definitely it should be defined from R to minus pi by 2 to plus pi by 2. So definitely student, this R and this R both are to be same. That's why we are saying that this particular x belongs to the R. In this case, this outside function is tan inverse. So output will be provided according to the tan inverse theta. That's why the answer should be lie in the interval minus pi by 2 to plus. That's we have to write here minus pi by 2 to plus pi by 2. Is it to be clear? Suppose we are just taking an example, tan inverse of tan pi by 4. Suppose a very simple example we have to take here, tan inverse of tan pi by 4. Then answer should be pi by 4, no problem, because you can say that this pi by 4 belongs to this interval, so there should be no confusion. But suppose we have to take the example like this, tan inverse of tan 5 pi by 4, tan inverse of tan 5 pi by 4. Now what should be the answer? Answer will be 5 pi by 4 or not, we have to check this thing. So definitely student, this 5 pi by 4 does not belongs to this given interval. This 5 pi by 4 does not belongs to the given interval minus pi by 2 to plus pi by 2. Is it to be clear? So if this particular x does not belongs to this interval, then student, you can just convert and just we have to transform this x. Is it to be clear? And just we have to apply the some trigonometry. Then tan inverse, this 5 pi by 4 can be written as pi plus pi by 4. This will be written like this, no problem. So pi plus pi by 4 is again written as the 5 pi by 4, but you can just see the transformation tan of pi plus theta. So definitely student, tan pi plus theta is again said to be the tan theta. So you can say that this will be again written as tan inverse of tan pi by 4. So after this part of transformation, you will get the answer as pi by 4. So in this case, answer is pi by 4, but in this case again answer is pi by 4. So in such type of calculations, just we have to see the basic type of transformation. So again in this case, we can say that if x does not belongs to minus pi by 2 to plus pi by 2 open interval, then transform the x, in such a way that x belongs to open interval minus pi by 2 to plus pi by 2. So this thing we have to keep in mind always. Is it to be clear? And according to that, we have to just do the processing of the given inverse trigonometric functions. Is it to be clear? So student, in each and every property, just we have to keep in mind this thing, this particular condition, and these particular conditions are to be the very important for us. We have to just use these type of conditions to solve the particular type of questions. And in this whole chapter, we have to just keep in mind the particular domain and codomain, or you can say that the principal value and the range, each and everything we have to keep in mind. Then we can just able to simplify the particular question. Is that to be clear? So next we will just discuss this property for the cot function, similarly for sec function, similarly for the cosec also. So now we will write each and everything here. So we will write each and every property. So student, in this very basic first property, we have to say that firstly sine of sine inverse x, sine of sine inverse x will be x if x belongs to minus 1 to plus 1. Similarly, in this second part, we are saying that cos of cos inverse x will be written as x. Again, we are saying that x belongs to minus 1 to plus 1. In third part, we are saying that tan of tan inverse of x. Again, this is said to be x, but where x belongs to the any kind of real number. And here no problem, if you can take any kind of real number, then definitely answer is obtained as r. Similarly, in the fourth part, we can say that cot of cot inverse x. So cot of cot inverse x is again said to be x, where x belongs to the r, because again you can just check the cot function and you know very well about the domain and codomain of cot function. So codomain of cot function will be set of real number always, so there should be no problem. Next we will check for the sec of sec inverse x. That should be x, but in what cases? If x belongs to r minus 1 to 1, because you can say that the range of this particular sec function should be r minus of minus 1 to plus 1. Is it to be clear? Similarly, in the last part, we are saying that cosec of cosec inverse x. So this will be again taken as x, but where? When we have to say that this particular x belongs to the r minus 1 to plus 1. So in this property, we have to see, write the property for each and every trigonometric function, and just we have to keep in mind this thing, student. We have to just keep in mind, because these properties will hold only that cases where this particular x lie according to the interval. And if in these cases this particular x does not lie in the given interval, then we can say that answer cannot be determined. So for each and every part that should be available here, we can write one thing: x does not belongs to given interval. You can say that x does not belongs to given interval, then answer cannot be determined. Answer cannot be determined always. So we have to keep in mind this thing always for these type of part. Suppose any of the x, suppose we are taking given interval, means these given intervals, we have to see these given intervals. Suppose this x does not belongs to these intervals, then we can say that answer cannot be determined. So this thing we have to just simplify here. Corresponding part we have to just write in such a way that sine inverse of sine x, will be taken as x, but when x belongs to taken from minus pi by 2 to plus pi by 2, and we have to take the close interval. Similarly, we can just write down the answer cos inverse of cos x. This will be taken as x, but when x belongs to 0 to pi close interval. And student, you know very well these are the principal value of cos inverse, sine inverse, and we have to already discuss about these type of values earlier in the section. So next, tan inverse of tan x. So this will be taken as x if x belongs to this particular thing will be lie from minus pi by 2 to pi by 2, but we have to take the open interval, means both the values, both the boundary values are not said to be included here. In the fourth part, cot inverse of cot x. So this will be taken as x and this will be taken as x, then definitely this particular x belongs to open interval 0 to pi. Fifth part, we are saying that sec inverse of sec x. So sec inverse of sec x will be taken as x, but when? But it will be taken as x if this particular x belongs to. Now you can just remember the principal value of sec inverse. So this is to be taken from 0 to pi except of pi by 2, except of pi by 2. And finally we will write this part for cosec inverse. So cosec inverse of cosec x will become equals to x, and if x belongs to minus pi by 2 to plus pi by 2 except of 0. Student, just we are writing the all the range part of the function sine, cos, tan, cot, sec and cosec, and here we have to just write the principal values of this inverse here. So we have to keep in mind this thing. That's why I am saying again and again, because these particular parts are to be very important in the case of inverse. If we have to keep in mind these things, then definitely we have to see the answer. But in this case, in this whole case, we are saying that if x does not belongs to given interval, x does not belongs to given interval, then transform the x, then transform the x according to required interval. You can say that according to the required interval. Required interval means according to the given function, which type of interval is to be get required to use the property. So according to that we have to just convert or just transform the particular x. But in this case, if x does not belong to the given interval, then answer cannot be determined here. So these things we have to keep in mind. So this is the very basic and first property related to the inverse trigonometric function, student. And we have to just keep in mind the domain, codomain, principal value of each and every kind of trigonometric function as well as the inverse trigonometric function, so that easily you can get the answer of each and every kind of question. Is it to be clear? So this is the very basic and first property. We have to just learn this property again and again, and we will just simplify the some basic examples also, so that easily you have to just clarify the property and how the particular answer is to be get obtained. We have to see this thing. Is it to be clear? That's why we have to just keep in mind the particular x, means this particular x will be lie from which interval to which interval. And similarly in such kind of cases, some of the student will get confused here, because here sine and sine inverse and here sine inverse and sine x. So student, we have to just keep in mind the outside function. According to that we have to write here the answer is x, here the answer is x, no problem. But some of the student will get confused, outside function is what, sine inverse or sine. So definitely we have to just keep in mind the outside function. We have to see the outside function, and according to that we have to use the principal value of that function or range of that function. Is it to be clear? So in such a way, if we have to write this property again and again without seeing the copy part, so that definitely you can learn and you can understand the part, and you can just able to use the properties to solve the questions also. Is it to be clear? So student, in this video just we have to discuss the very basic and first property related to the inverse trigonometric functions. Is it to be clear? Now student, this property will be very helpful for us in the very first exercise 2.1 that should be given your 12th NCERT mathematics of inverse trigonometric function. So we will just simplify that exercise, as well as we have to see the some basic part also related to the property, and then we will just simplify the exercise 2.1 in the next video. But before that student, again I am saying the principal values are to be very important for each and every student to give the proper answer of each and every given trigonometric functions. After student just reading the part, we will just discuss about the graph of sine inverse of sine x, cos inverse of cos x. These graphs I will just discuss with you, because in different type of conditions these graphs will be proceed in a different way, and with the help of graph sometime we can just able to solve the particular type of questions also. Is it to be clear? So thank you student. We will meet with the some basic and more properties related to the inverse trigonometric function in the next video, and we will just simplify the exercise 2.1 of your 12th NCERT mathematics also, so that you have to just read the property carefully and learn the each and everything carefully, so that easily you can just able to solve the particular given type of questions. Thank you.